Hello everyone. Today we are going to see the ownership concept in host programming language. What is ownership in host programming language? In fact, ownership is a core feature that ensures memory safety without a garbage collector. If you are familiar with a language like Java, C++ or Python, you will see how host approach is unique and powerful. Let's start with a simple example. Let's say give me a variable s and inside assign a string yellow and give me another variable s1 and inside this variable assign the s that we previously declared. Now print this variable s. Yes, we will have a compile error here. Why? Because in host the ownership is moved when we assign the first variable to another variable, like we did on this statement. And if we say instead print the variable s1, it will work. You have the result here. Okay, the other thing is that let's say we have a variable s already, and now you want to add another string on this variable, and you want to add a word string inside. We still have a compile error here. Why? Because in host each variable that we declare is by default immutable. To make it mutable, we need to add a keyword mut when we declare the variable here, and the error is not there anymore. So why previously the string moved from the variable s to the variable s1 and making the variable s invalid? It's because in host programming language it prevents the use of the move bug. Let's take another example. Give me s variable and assign a string inside. Put hello. Now give me another variable r1 and inside variable assign s. Another variable r2, inside it assign also s. And this statement we will have an error because I previously see the in host programming the variable ownership is moved to the other one when we make the assignment. To make it possible to assign the same variable to another variable here, we have to put another keyword here on the s variable, the ampersand, and also here the ampersand. This keyword ampersand make a borrowing of the ownership. So right now this r variable get the borrowed ownership from the variable s. Now if you try to print the two variables we created, r1 and r2, everything is working good. But now what's happen if I want to add some value inside the r1 variable, like this, maybe a space word? I had a compile error here. Why? Because the r1 variable is not mutable. If I put the keyword mut here, it will not fix the issue. Why? Because even the s is not a mutable variable. This mutable r1 variable refers to the another variable that is not mutable. If I add another keyword mutable here on the s variable, yeah, I will still have the issue here. Why? Because I need to make this s variable to mutable when I'm making the assignment. To do that, I need to instead put a mut variable keyword here for the s. And in this case, it's not necessary to put the mut keyword on the r1 variable here. Now everything will be work. And let's say I want to print this variable r1. I have the hello world. This r1 was updated from the variable s1. Another thing to know here is that you cannot mix borrows. Let's say here that gives me a variable r1 and inside assign a reference of the s1 of the s variable, the reference, and now you say again give me another variable r3 and assign the same s variable but has a mutable. If you try to print r1 instead here like this, you will have an error here, a compile error. Why? Because you cannot mix a borrow. You have to finish using immutable borrows before creating a mutable one. This is the tip. Okay, now let's take another example that is more complex. We are going to use the ownership in the collection. Let's say give me a mutable v who is a macro vec and initialize it. Now give me a variable s, assign a string inside the vect variable, push the value s, and now let's try to print our variable s. We will have an error compile time here. Why? Because when in the collection also, when we are using the vect here and we push that variable inside that vect, the ownership was moved from the variable s to the vector v. To fix that error compile issue, we can just add a keyword ampersand here and it will work. If you run our apps, it will display the hero. Or we can also clone that string using the method clone like this. It will still work. So be careful on this statement when you are using this function on the string. In fact, this function cloning a copy data, so use it sparingly for performance. Okay, now let's take another example with another collection. Now give me a mutable map who is a hash map, initialize it. Then give me a key who is a string and initialize it with a string from, let's say, numbers. Give me another variable that called value who is up and put the value 1, 2, 3. Now in that map you create before, insert that two variable key and value. Try to print that map. And we have the result, of course. Now what happens if I want to print also the other variable key and value? I have a compile error. Why? Because on this statement the ownership of the variable key and value was moved to the variable map who is a hash map, a collection hash map. So to fix that, as I did before, we can just borrow the ownership here during this statement using the keyword ampersand, and also the same for the value. Now we don't have the error compile time anymore, and we are able to print also the variable k and the variable value. So in summary, why ownership matters? In Rust, ownership prevents memory bugs like dangling pointers or double freeze at compile time. Unlike garbage collected language like in Java, HOS gives you control over memory with zero runtime overhead, making it ideal for system programming. This is the end of this video today. So thank you for your watching and see you next time. Happy coding.